we need to take negative 32 x squared y cubed and write it into two pieces. The perfect cube, and then what's left over. And if I look at my table of cubes, I want the largest cube, here's the cubes, that divides 32 evenly. Well, 27 doesn't divide 32, but 8 divides 32. So that'll be the largest cube, is 8. So since it's a negative 32, this would be a negative 8. And to make 32, the leftover would be 4. X squared is not a cube because in order to have a cube, you need to have 3 x's. I only have 2. So he goes into the leftover. And y cubed is a cube because I've got 3 of them. Now I use the product rule for radicals. And again, this is a step that you can, some of you will skip, but essentially you end up doing it mentally. Make sure you put your index in. This is negative 8y cubed. This is 4x squared. The cube root of negative 8y cubed is negative 2y, and times what's left over. So that's the last of the guided ones. So here we go. First thing I do is I look at, this is a square root. So now I'm going to be doing squares. And I notice from a numerical point of view, I go down the list of squares. 64 is in my list, so 64 is a square. And then I'm going to be looking at what? Groups of 2, even number of variables. So I look to see, I break this guy up into 2 pieces. The square, which is 64, x squared is a square. This is y to the 1 power. Using the product rule for radicals, I'm going to belabor the point. I break it up into my 2 pieces. The square root of 64 is 8. The square root of x squared is x. Square roots of y. Now, I envision when I do the problem myself, I normally stop here, and then I pretend like I'm taking this square root and I push it back to that bar, and as I push it back, it performs the root. The square root of 64 is 8, the square root of x squared is x. It stops right there, and it gives me this guy. That's kind of how I look at it. Now I've got a cube root. That means I need the largest number that divides 32 evenly. And we can see it's going to be 8 in my list of cubes. So I need to break this into 2 pieces. 8 and 4, that's 32. Now, x to the 4th has a cube in it. What's the cube in x to the 4th? X to the 3 with how many left over? X, 1. Now, product rule of radicals, it's 8x cubed times the cube root of 4x. Cube root of 8x cubed is 2x. Cube root of 4x. Now notice how careful I am to make sure that that 3 goes right into that little v part. Because if I've got it too close, I'll either think it's an x cubed or I'll think it's a 3 times. Now, this is where you have to be careful. This is 5 times the fourth root. So it's 5 times, it's now a fourth root. This is where working fast is not your friend. Fourth root, 64. So I'm going to go down the list. What is the largest number? 16 is going to be the biggest when you come right down to it. Because if I go down, what are my fourths? 1, 16, 81. So of the list, what's the only thing that's going to work? Is 16. And what do I multiply 16 by to get 64? And use your calculators if you need to. All I'm looking for is groups of 4. What is the largest power before 7 that's divisible by 4? 4. And if I'm taking 4 of them, how many are left over? 3. And is 8 divisible by 4? Yes. Oh, do I really want to do y? I don't have room for y. Okay, I got to smash him in. What's the largest number before 10 that's divisible by 4? 8. And how many do I have left over? 2. So let me clean this up so we can actually see it clearly. It's my bad. That's what it should look like. So now, in my mind, I'm pushing this radical back and then it hits the wall, because that's what's going to be left under the radical. So, product rule for radicals, it's 5 times, I don't want to lose that 5, the fourth root of 16x to the fourth. Again, you do not need to put this step in if you don't have to. There's the break point. Now, if I take the fourth root of 16, it is?
2.
So it's 5 times whatever comes out of this guy, which is 2. Fourth root of x to the fourth is? Y to the eighth is? Z to the eighth is? And then I've got this radical thing left over, so this is all times. Now, 5 times 2 is 10, x, y squared, z squared, square root of 4x cubed. And I'm not, look at that. Do you see what I just did?
You did square root.
I did square root. Now, if I'm doing a square root, I'm not done. But what root am I supposed to have?
4.
And what didn't I do? I wasn't careful. Even me, I forget to put my index in. So I'm yelling at you about being careful and slow. So then that's your answer. Now, as with product rules, there's a quotient rule too, which says I just take the cube root of the numerator divided by the cube root of the denominator. And the denominator is easy, at least at this point, because what's the cube root of 125? 5. Now I've got this mess in the numerator. 108 is not a cube. So now I go down my list of cubes. What divides evenly 108? Well, does 64? I don't know.
No, it's 27.
So what would I do? I come out to use my calculator and say 108 does 64 divided evenly? No. Nope. 27. 108 divide 27. This is exactly what I would do. 4. So it's 27 and 4. And x to the sixth is a cube because it's divisible by 3. It's two groups of 3. So this is, the cube root of 27 is 3. X to the sixth is x to the 3. It's x to the 2. Thank you. And then the 4 is on his own. Now look at that. This is all recorded for posterity until I re-record something. Cube root of